And that's it for this question. Okay, so let's look at the next question. Question 10. Eva is a member of a sea swimming club. The club has 6 markers in the water labeled A, B, C, D, E, and F as shown in the diagram below. A, B, C, D, E, and F is a 6-sided shape where AF is parallel to CD. So AF is parallel to CD and AF is perpendicular to AC. So this is a right angle here and a right angle here. AB is equal to CD is equal to EF is equal to FA is equal to 200. They're unmarked. BC is equal to DE is equal to 150. Those two are marked as well. Eva swims from A to B, C to D, D to E, E to F, and back to A again. Find the total distance. Oh dear, okay, so this is just a case of adding. So look, you've got to take 200, add 150, add 200, add 150, add 200, and add 200. So when you do all of that, you get 1100, and meters are the units. Okay, so that's number 1, very easy start. Let's have a look at part 2. The size of the angle ABC is 110 degrees. Work out the area correct to the nearest square meter of the triangle ABC, that is the area of the shaded region in the diagram above. So we've got to find the area of this triangle here. So we can see that we've got this side, and we have the enclosed angle. So that means we can use the formula half AB sine C. A is 150, B is 200, and C, the angle C is going to be 110. So let's do that. So the area is equal to half AB sine C. In our case, we've got a half times 150 times 200, and then we've got to get the sine of the angle between those two sides, which is 110 degrees. So look, all of that is just calculator work. We have to give our answer to the nearest meter. So that's 14095 meters squared. Okay, so the third one then, Eva swims straight from A to C. Use the cosine rule to work out the distance from A to C. Give your answer correct to the nearest meter. Okay, so they're telling us what to do here. So we've got to find this distance here from A to C. So again, we have two sides in the enclosed angle, and we need to find the opposite side to the angle. So we can use the cosine rule. So let's just write that out. So it's going to be the distance from A to C, which we got to square. And then it's equal to the two sides squared. So it's 200 squared plus 150 squared. Minus twice the two sides multiplied, so it's 200 times 150, and then we got to get the cosine of the angle between those, which was 110 degrees. So you just got to work through all of that. I mean, if you do these two first, you'll get 62500, and then if you do these ones, you'll get minus 60000. 60,000, and then we got the cos of 110 as well. Okay, so AC squared, when you do all of this on the right hand side, you will get 83021.2086. We've got to get the square root of both sides to get rid of that 2 up here. So when you get the square root of the right hand side, and round it to the nearest meter, so it's going to be 288 meters. Okay, number 4 then. Hence or otherwise, work out the total area of the water enclosed by the 6 markers. So if we look here, what we've got is we've got a rectangle here anyway, and we have 2 triangles. And these 2 triangles are actually the same area because we've got 150 and 200. We've got 150 and 200. And this distance here is the same. We've just worked that out as 288 meters. So I'm going to find, well, we've already found actually the area of this triangle here. So all we've got to do is double that. That'll give us the 2 triangle areas. Then add those to the area of the rectangle in the middle, which is just 200 times 288. So let's do all of that. So the area of the triangle, so the total area, the area of the triangle was 14095, and we've got to double that because there are two of them. And then we're going to add the area of the rectangle in the middle. So that's just 200 multiplied by 288. And that's really it. When you do all of that, again, it's all just calculator work. So it's 85790, and that is in meters squared. Okay, so next one. Point A is the nearest point to the shore and is the start and end point for all swims. Ava wants to see how many routes she could swim starting at A by swimming to each of the 5 markers B, C, D, E, F once and only once, and finishing at A. So she could do from A to E, then over to C, then to F, then to D, and then back to A again. So that's one such route she could do. So we have to do another one. So what I'm going to say is from A to C to E to B, F, D, and A. So she can start at A, go to C, go to E, then she can go to B, then she can go to F, then she can go up to D, and then down to A again. Okay, so that's that one. How many such routes are possible is the next thing. So if we look at this kind of thing here, I'm just going to draw some boxes here. So I've drawn 7 boxes here. We're going to multiply the numbers in these boxes here. Now she must start at A, so that means there's only one possibility here, and that's A. At the end, she must finish at A, so there's only one possibility out at the end, and that's A as well. So in between then, how many possibilities has she got here? Well, if she starts at A, there are 5 other markers, so she has 5 choices there. Once she's picked one of those markers, she has only 4 left to choose from. And once she's picked one of those, she has only 3 left here to choose from. Once she's picked those 3, then she has only 2 left and 1 left here. So if you multiply all of those, you will get 120 routes. That's it. Okay, next one then. On a particular day, Ava wants to start at A, swim to 2 markers other than A, and then return to A. For example, she could do A, E, B, and A. Work out how many of these routes are possible. Well, again, if we do 4 boxes here, multiply our numbers. So she has to start at A and finish at A. So she only has one possibility there, A. At the end, she has to finish at A, so there's only one possibility there. So after she leaves A, she has 5 other choices for her second marker. And then once she's picked that one marker, she has 4 markers left to choose from there. So really there are 20 routes that she can choose. Okay, and that is it for this question and this paper.